All right, welcome back. For specific particular lessons during this unit, we are going to be doing some note-taking from the textbook. And so we'll start with this exploration here that will help us kind of get back in the groove with the transformations of the quadratic parent function. This is a review from the beginning of Unit 1, so these should be pretty simple and pretty straightforward, but we're going to revisit this so that this is fresh in our mind throughout the quadratics unit. What we're going to do is we're going to again address the idea of A, H, and K affecting a quadratic parent function using a specific set of parameters. Remember that this is the vertex form of the quadratic parent function, and we're going to use this small exploration to help us determine what A, H, and K do. So through this first little exercise, we're going to do a matching activity, and you're going to want to go ahead and pause the video right now, and according to the instructions, you want to work through these 6 problems and match them up to the graph, stating the transformation and then matching them up here. All right, hopefully you took the time to work through that prior to seeing this. Here are your matching values, and here are the reasons for each of those transformations and how you match those up. All right, we're going to take a look at A, H, and K specifically so that you guys can have a clear understanding of their effects. As I said, again, this is just review, but we just got to talk about it one more time. So A is a multiplier, which is on the outside of the parent function. Therefore, A, when it's greater than 1, represents a vertical stretch. And A, when it is a fraction between 0 and 1, represents a vertical compression. When A is switched from positive to negative or vice versa, a reflection across the x-axis occurs. H is a right or left movement, and remember, anything on the inside of parentheses has an opposite effect of what you would think because of the way the equation is written. K is up or down. Because it's on the outside, it has the same effect as what you would believe. The value that is missing from our prior explorations is B. Remember, B is your horizontal stretch and compression, and if it's positive to negative, represents a reflection across the y-axis. What we're going to do now is we're going to write the equation of the quadratic function that is shown. We're going to explain how we got that by looking at the original parent function, which I will sketch onto the graph approximately like this. All right, based on that movement, we're going to decide what happens here. That's 1, 2, 3, 4, 5, 6, so we're counting by ones. So I'm going to go to the right 1, and it looks like I'm counting by ones on the y-axis as well, so that means it's going to be down 1, 2. Now we're going to go ahead and write this as a function, f of x, using function notation. And remember, the parent function is y equals x squared. So this is going to be f of x equals x minus 1 squared minus 2. Now the next thing I need to do here is I need to address a vertical stretch or a vertical compression. And I'm going to address that by looking at this particular group of points here. I know if I go over 1 and up 1 on this parabola, the parent function parabola, that I am back on the parabola again. I know that the vertex of this is at 1, negative 2, and it looks to me that this crosses, that has a y-intercept of 0, negative 1. That means that if I go over 1 and up 1, I'm back on the parabola again, and that's how I know that the vertical stretch for this is still 1. There is no stretch or compression for this particular problem. All right, we'll take a look at a few definitions now so that you guys have some clear understanding about the things you are defining in this particular lesson. A quadratic function is the parent function y equals x squared, which when is graphed is a parabola. A parabola is the name of the graph of the quadratic parent function, and the vertex of the parabola is on the line of symmetry. It's can be considered the turning point of the parabola and is the center of the graph of a parabola. Vertex form is the form y equals a times x minus h squared plus k, and it can be used to find the vertex of the parabola at the value hk. The axis of symmetry will be x equals h, and there are a few other things that we can find from that, but those are some pretty important points that you're going to be looking at. All right, moving on down here, we're going to take a look at some horizontal and vertical translations of the parent function. And these notes are already filled in for you, so it's kind of nice that you just get to look through them and make some notes. The thing that I would notice here is that because the h is on the inside of parentheses, it has the opposite movement than you would believe. Okay, it's always shown on the inside of parentheses. If you don't see parentheses, assume that it is a vertical stretch, and it is always the opposite direction of the symbol. With a vertical stretch or a vertical translation, it's always going to be outside the parentheses, and it's always going to be the same direction as your symbol. And finally, we're going to look at some reflections here of your quadratic parent function, including stretches and compressions. So we'll start with our reflections. Notice that this is the value of b being switched because it's on the inside. This is the value of a being switched because it's on the outside. Notice that because of symmetry of a parabola, you'll note that there is no visible or visual change to the parabola itself. Instead, there is a reflection, but it just maps back onto itself again. Here you do see that switch because it reflects upwards to downwards. Horizontal stretches and compressions. Notice the value of a has been placed on the inside of parentheses. Now this could be confusing, but remember, to avoid that confusion, we just change that value to b instead. And then your vertical stretch and compression is exactly what we've seen in the past. Notice that it's the opposite, okay? And a stretch will occur when you have a fraction on the inside of parentheses, and a compression will occur when you have a whole number greater than 1 inside the parentheses. Think of it as water. Water compresses airspace as it gets bigger, and then water allows airspace to expand as it gets smaller. So the thing that I wanted to point out to you when you're dealing with multipliers and reflections is that in order to avoid the confusion of transforming these functions properly onto a graph, you always want to start with your reflections and then stretches and compressions, followed by any of your translations that you're going to want to do. And this just is consistent with PEMDAS. You want to do order of operations, and since stretches and compressions as well as reflections actually represent multiplication in the problem, you're doing that first anyway. But that's just a helpful hint to keep it straight in your mind as you're moving forward. All right, the next bit is going to be something that you do on your own. I'm going to go ahead and check this tomorrow at the beginning of class. So although your video responsibilities are about to be finished, you've got to do a little bit of work through the extra practice. Go ahead and describe the transformations and then graph the function. I want you to graph it accurately. Make sure that you have critical values placed on your graph so that we can see clearly where it is that you are graphing this, and that you have a clear understanding of how to graph a stretch or a compression if in fact there is one. All right, so there are 7 problems that I'd like you to do, so please have those ready to share at the beginning of class tomorrow.